Example 5. Describe the similarity transformation that maps quadrilateral DEFG to quadrilateral STUV. So again, make sure you pay attention. You have to get this one to that one. That way you know which direction you're going. So we have to get the blue one mapped onto the green one. The first thing I'm looking at is he's kind of in the wrong position. So we have to maybe turn him, rotate him, flip him, get him down here. And if I'm looking, take a real good look at where the green one is. If I take my whole picture and rotate him, it looks like that blue one might then go into place. If you remember where the green one was, he just might then be a little bit too large. So I'm thinking we're going to start with a rotation of 180 degrees. If you do that, there's a couple ways to think about it. So for example, point D is at -2, +3. If you rotate 180 degrees, you flip the sign on both the X and the Y. So instead of -2, +3, we're going to go +2, -3, and D would be sitting down here, which essentially would be like a D prime. G, instead of 0, 1, would be 0, -1. E, instead of 1, 4, would be -1, -4, because you flip both signs. And then F, which is at 4, 0, would be -4, 0. So right now, if we rotate it by 180 degrees, we'd be sitting right there. That looks like it's now in the correct position. We just have to get it smaller. So that means we're going to need a dilation. And our scale factor, because it has to get smaller, has to be less than 1. So I'm going to pick a point. I'm going to pick this guy. And this is at -1, -4. And I have to get it to T, which is at -1/2, -2. Well, in order to do that, -1 to -1/2, that's a half, and -4 to -2, that's also a half. So I'm thinking my scale factor should be to cut it in half. If I check another point, this one's at -4, 0. This one's at -2, 0. So -4 cut in half is -2. 0 cut in half is still 0. So my dilation checks out. So step 1 and step 2, that's our similarity transformation.